Hello, future scientists of Uganda. Today we're diving into physics, but not the old boring kind. The new lower secondary curriculum is about thinking, doing, and understanding, not just memorizing facts. It's competency-based, meaning you'll build real skills for real life. You'll solve problems like figuring out why a pot boils faster with a lid, or how to set up a solar panel. Assessments now test how you think and connect ideas, not just what you remember. Science is everywhere, and this approach prepares you for the world outside the classroom. You'll learn to observe, think logically, and communicate clearly, skills for any career. We'll show you how to tackle every type of question, use your scientific tools, and present your answers like a pro. By the end, you'll see assessments as a chance to show off your brain power. Science is cool, and you're going to be great at it. Let's get started. Let's break down the types of questions you'll face. Structured questions guide you step by step. Define, calculate, explain. Scenario-based questions put physics into real-life stories, like a boda driver saving fuel. Practical questions test your hands-on skills. Describe an experiment or interpret results. Problem-solving questions are puzzles. Use formulas and logic to find solutions. Extended response questions ask you to explain ideas in detail, like discussing hydroelectric power in Uganda. Each type tests a different skill, knowledge, application, experiment, calculation, or critical thinking. Recognizing the question type helps you answer it the right way. Think of it as having the right key for every lock. Practice spotting these types in your homework and past papers. The more you practice, the more confident you'll become. Soon, you'll know exactly how to approach any question. Let's unlock your physics potential. Here's your superpower. Reading questions like a detective. Always read the question twice, looking for instruction words. Describe, explain, calculate, compare, suggest. Spot the topic words, force, mass, voltage, resistance, to know which physics area you're in. Pay attention to context, numbers, and units. They're clues for your answer. If units don't match, you may need to convert them. Rephrase the question in your own words to be sure you understand what's being asked. For example, if asked about evaporation, think, how does the sun make water disappear? Careful reading prevents mistakes and helps you give the answer examiners want. The best students are careful detectives. Be one. Let's solve every question with confidence. Your physics toolkit formulas, units, and clear calculations. When asked to calculate, write down the correct formula first. It shows you know your stuff. Substitute the numbers, include units, and show every step. Never just write the final answer, show you're working. Even if you make a small mistake, you can still earn marks for the right method. Always include the correct unit, meters, kilograms, joules, newtons. Otherwise, your answer is incomplete. Keep your work neat and organized. Answer multi-part questions in order. Use bullet points or short paragraphs for clarity. Double-check your units and calculations before moving on. A neat answer is easier to mark and shows clear thinking. Master your toolkit and you'll build strong answers every time. Let's calculate like pros. Physics mastery is more than just getting the answer. It's about thinking like a scientist. Justify your answers, explain why, not just what. Suggest improvements for experiments, be creative and practical. Predict outcomes using physics principles like what happens when you add a bulb to a circuit. Apply your knowledge to real-life examples, why a sharp knife cuts better, or why tractors have wide tires. Don't just memorize, understand the why behind every concept. Connect physics to everyday life for deeper understanding. Critical thinking and application are what the new curriculum values most. Practice explaining your reasoning in every answer. That's how you become a physics champion. You've answered the questions. Now review your work. Leave a few minutes to check every answer. Did you answer every part? Check calculations and units. Read your explanations. Are they clear and logical? Fix any small mistakes you spot. After the assessment, reflect on your strengths and areas to improve. Read your teacher's feedback and learn from it. Try peer review. Explaining concepts to friends deepens your understanding. Remember, mastering physics assessments is a skill you can build. Read questions carefully, apply knowledge, show your steps, and think critically. Review and reflect to keep improving. You have the tools and the brain power. Go out there and show what you can do. Science is for everyone, including you.